Okay, students, so last time we were to work on a yin-yang design or drawing in your processing platform and submit that. So the instructions previous to that are on the PowerPoint presentation that's located on my website. And I have that up here in front of us right now, but the location of that, just in case you needed to find it, it is right here underneath Introduction to Processing Shapes, Variables, Loops, Functions, or Animations and Arrays. So that's what we're going to be continuing to work on today. And we just finished up with, with your yin-yang sketch. So we're going to be moving on to variables. Variables are real handy and a powerful tool within programming and coding. It saves the coder a lot of time to manipulate the data that's in the code if variables are in place, because you can manipulate the variable at the beginning and it populates that number or value throughout the remainder of your code. So it does save a lot of time for programmers to use variables wisely and to name them very well so we know what they represent. So variables can be used for a variety of things. If you wanted to track something, you could add one to that variable, and it'd be like a counter or a scoreboard or something of that nature. You could save values and come back to that later. So by definition, a variable contains some known or unknown quantity or information, a value. So here are some examples. Variables can be not just necessarily numbers or letters. They can be a variety of different things. So within processing, here are a few examples. If you wanted to do just a character, one letter of the alphabet, whether capital or lowercase, that is a char or a character. So you need to tell the type of variable. This is a character. You need to name your variable, and then you need to instantiate it with a value. For instance, on this one, this is an integer. We have called it by the variable I, and we've assigned a value of 100 to it. So you need to identify the type, the variable name, and the value. So in this one here, it is a floating point, so it's a float. We have named that variable x. In a float is values that contain decimal points. So you can have whole numbers and decimal points using a float. Now, if you have more than one letter, it would be considered a string, and it's a capital string. And you name the variable, and then in quotations you're going to put in what that string value, what word or characters are stored in that variable. Okay, so here's an example of creating 3 circles using variables. Now, once I have identified my y, which is my y coordinates, we have x's changed, we have our y's, and our diameters. So this is relatively easy to kind of picture in your head. We're going to have 3 circles. X values travel horizontally, so we're going to see them going across the top of the grid, and they're all going to be of the same shape and in a line, I believe. So I believe I can copy this out and throw it in a processing platform. Not sure if it'll run straight from that. Like we said, so we have 3 circles. They're just going to be increased by the x value along the x-axis. So looking at this, they are 100 apart. So now if I wanted to manipulate that to some degree, you could change these values to either make them closer together or farther apart. But it's real nice to manipulate. Say, for instance, I wanted them to be a little bit bigger. I would just simply change the value of the diameter right here, run it again, very little change on my part, and now we have 3 different size circles, still at the same location, x and y coordinates, but now their diameter is large. In fact, that program to make it a little bit easier to draw these circles and to change the diameters and the y locations, etc. So that's one of the reasons why an example of why we would use variables. Let's continue through here, and I'm going to save that. Just continuing down. So here's a variable program. It's going to print out 4 red lines, 4 red horizontal lines separated by about 10 pixels, it looks like. So if you see here, we have our setup. It's in a window, 300 by 300. The background is black. The stroke is going to be red. The weight is going to be 4. And then we have our variables 50 for A, B is 120, C is 180, and the distance is 10. So line 1 is going to be at 50, 120, so that's your x and y, 50x, 120y. And it's going to continue from that point to the secondary point, which begins at A plus C. So that's at 230 and ends at B, which is A plus C, sorry, not 230. A and C is going to be 180, 230, yep. And it ends at B, which is 120. So that's going to be your x and y here. So A plus C, that's the x over, and then B is the down. So let's check if we can copy this into our processing platform and run it and see if we do get those nice 3 or 4 red lines. So I'm going to copy, go into here, do a new sketch. I'm going to paste it, and then I'm going to run it. So there we go. We have our 4 nice, neat lines there. Pretty good. So you can see that we are using these values, and then you can multiply to them. So if distance is 10, 2 times distance is going to be 20, 3 times distance is 30. So that would provide your separation between those lines. So using variables, a powerful thing in processing and something you should get familiar with. So here's some programs. Your processing platform does have some built-in examples, and I'm going to show you how to load those right now. So I have some already loaded. So if you went into a sketch, let's say for instance right here that we just drew, under File, you're going to have a place to get examples. Now, yours might not look like mine because I have added examples. I'm going to show you what to do to add as many examples as you would like. So right here you see Add Examples. Now I have added these two. The slides that we're going through are using the library right here, the second one, Getting Started with Processing Second Edition. So I've imported 2 different ones into this. So if I wanted to import a third one, which is not necessary, you just need this second one. If I did that, I would click here. I see I have install. I install that, and then it shows up here in my examples under contributed examples. Right here, I'll see. So I have those 2 books. Like I said, the one that we really need to focus on is Getting Started with Processing Second Edition, because it gives you an example here that we want to look at for a variable program. Contribute examples, chapter 4, 4-03. So let's take a look at that. So we go to File, Examples, Contribute Examples. Now this is the library just imported, was that first one, chapter 4, 403. 2 clicks on that and it will bring up the program for you. So all of these examples that we have access to are really cool, and they've got a lot of things going on. So if you want to learn how to start, draw, variables, response, transform, media, motion, functions, objects, arrays, we have a bunch of data, a bunch of programs and examples preloaded in processing for you to go through and to use as you see fit. So let's run this and see what it does for us. It's going to create a crossing lines with an ellipse in the center. Okay, so let's close that out and go back over here. So variable programs. Here's another thing that is done within processing. When you identify the size of your screen with size, width, height parameters, this 480 is now stored as a variable or accessible with the variable term width. So they could be interchangeable. So when I type in width in processing, it is going to refer to the parameter, the first parameter in size, which is the width of the screen. Now this makes your projects or your programs dynamic, because if I am using my width and my height as anchor points to determine the values of my variables and the sizes of my shapes and drawings, I can go in and change the size of my window, and my sketch will not become disproportionate. It will just continue to grow or shrink based upon the size that I indicate here, but then those variables are updated. So just like I changed the diameter of that circle in a previous example, I can change width by adjusting the size of my window. So let's run this real quick and see what this looks like. I just simply copy and paste right from the PowerPoint into here. And there we go. And I'm going to run this and see what it looks like. So it's the same exact example that we had before, only now we are accessing this window to get our width and height here. So let's do some, so previously it was line from 0 to 480 and 120, but now we've updated that here with variables width and height. So I'm going to manipulate this a little bit and see how that changes our design. So instead of 120, I'm going to do 520. So now the height variable has been updated. It went from 120 to 520. So there, in this particular term here and here, we have a new size of a window, or a new value for height, sorry. So now you can still see that it does represent the similar drawing as before, only now our height has been changed a bunch. Now, with an ellipse, maybe I don't want to have 480. Maybe I need something like 240. Well, if I have 480 and I divide it by 2, that would get 240. So this ellipse, the x value for that first one, is going to be 240 because I'm dividing the width by 2. So using height and width is going to be very important for our assignment today and for future programming. So let's go through here, keep going. This is what your assignment is to be working on, is to refactor your yin-yang sketch so that it is drawn relative to a fixed point, such as the center of the yin-yang. So we want to refactor it using variables, and we want to use width and height as our anchor points for this. So let's go in and take a look here at a, no, wrong one. Right here, this is an example of our yin-yang. Now, we have a size 400 by 400. So if I wanted to manipulate this, that is width and height. So everywhere I can use this, I'm going to do that. So in my list, my x value, which is going horizontally, you want to tie your horizontal movements to your x coordinates. It makes more sense. If I'm moving along the x axis, I need to be relating to the width. So x coordinates relate to the width. Y coordinates are relative to the height. So for 200, that is half of the width, which is 400. So instead, I could go width divided by 2, and I would still get a nice looking yin-yang. So I can do that for every 200 value. I can copy that. Well, again, you only want to do it for the x values. So x, xy, I want to run frequently to make sure I didn't get something out of order. Still looks pretty good. Okay, so you need to refactor. Now again, like I said, the y coordinates need to be relative to height. So instead of doing width divided by 2, which is the same value, height divided by 2. That's going to be better, because then if I start manipulating this, it will proportionally increase or shrink your drawing size. So I should be able to run this again. It's still the same yin-yang, but I'm refactoring it at this point in time. So that's your job today, is to take your, and you could assign variables in here too as well. So I could go like int diameter equals 200. And now then, instead of having a 200 diameter there, I could just put a D for diameter. It probably would be better to be even more specific with this and say, let's make that our X diameter. So that would be better because we have a Y diameter as well. Sorry. Okay, so now then that 200 is being reflected right there. I run that. We should have the same shape. Good. Okay, so you're to refactor using variables and the anchor points of width and height to refactor your yin-yang project.